Okay, so for 11.7, number 3, Chen was asking this question here. He says the alternating series test comes out to 1, so that doesn't work, which, yeah, it does. The ratio test we're going to try next because that's typically what we do next. So we have a sub n is this. A sub n plus 1 would be n plus 1 over n plus 1 plus 2 or n plus 3, right? And then I do a sub n plus 1 over a sub n. So I have n plus 1 over n plus 3. And instead of dividing by this, I'm going to multiply by the reciprocal. And my n's are all positive, so do I really need the absolute value pieces? No, right? So I'm going to take the limit as n goes to infinity of, and I'm going to multiply the numerator out, so I get n squared plus 3n plus 2. And in the bottom I have n squared plus 3n, so I end up with 1, right? So that's inconclusive. So I can't do the root test because that would be inconclusive. Remember, if one is, the other is going to be. Let's see. So alternating series doesn't work. That doesn't work. We could just do an absolutely convergent or divergent. Can I just do the test for divergence? Why not? This should be convergent? Why can't I use the test for divergence? Or if it does not equal 0. Yeah, I was looking at the test for divergence and saying if I take the limit as n goes to infinity, the absolute value of that, it would be 1. But just because it's absolutely divergent doesn't mean it would be divergent. That's only for convergence. All right, so what we're going to do here is if I take the limit of the absolute value of a sub n as n goes to infinity, what's that going to be? Yeah, which is going to give me what? 1, right? Because I have just this piece here, divide everything by n, we just get 1. All right, that makes sense? So if I take the limit of that whole thing, because you can't just do absolutely divergent, so we have negative 1 to the n over n plus 2. Isn't that just going to switch from positive 1 to negative 1 to positive 1 to negative 1? So is that going to 0? No. Okay, it actually does not exist. So if you look at the test for divergence, if the limit does not exist or it's not equal to 0, then it's divergent. So we can use the test for divergence, but you can't just say because this is 1, it's divergent. Okay, because it's the absolute value of it. You have to say because the whole thing does not exist, then it's divergent by the test for divergence. Make sense? So it's not convergent, even though I was told it was. Other questions? All right, for this one here, if I plug 1 in, I would just get what in the numerator? If I plug it into here? 1, right? So that's this first piece. And then the denominator, I get 2. So that's this first piece. So if I'm at n equals 1, that's just 1/2, right? Then the next one, if I plug 2 in, I would get what? 3 and 5, right? But what I'm doing is I'm taking 1 times 3, so that's why it has this piece in the front. It's not just this like you're thinking, okay? So it's 1 times 3, and then the bottom is 2 times 5. Now if I plug 3 in, I get 5, right? So I go 1 times 3 times 5 in the numerator. And in the denominator, I take 2 times 5 times 8. Do you see how this is working? All right, so you got to be careful of just saying, oh, it's just this. Because it's not just 5 over 8, it's 1 times 3 times 5 over 1, or 2 times 5 times 8, okay? So this one might end up being a little more complex than we were thinking initially. Looking at the different tests I can use, I'm thinking it's obviously not alternating. I'm thinking the ratio test because I think some stuff will cancel, so that's what I'm going to go with here, okay? Let's give it a try and see what we come up with. And if it doesn't work, we'll try something else. Okay, so for my ratio test, I need a sub n, which is this whole thing, right? 1 times 3 times 5 times 2n minus 1. And the nice thing is if I do this, stuff is going to cancel like crazy, right? A sub n plus 1 is 1 times 3 times 5, dot, dot, dot. And then now if I plug in n plus 1, it's 2 times n plus 1 minus 1, which I can clean that up in a second. And the bottom, same idea. Do you see how all these terms out in the front are going to cancel each other, which is nice? And this would be 3 times n plus 1 minus 1. They're not going to give you a ton of problems that are super, super difficult like this. I mean, they're going to give you a lot where just to make sure you know the tests. So if you know the tests, you'll know how to do most of them. These would be more like the problems that are going to differentiate between like the 3s, 4s, and 5s, you know. So if we've got our tests down, we're going to be able to do most of them. Okay, so back here, this is going to turn into 2n plus 2 plus 1, right? Or minus 1. So it's going to be 2n plus 1 total. Makes sense? And the term before that is going to be what? 2n minus 1, which is going to end up canceling with this, which is why I want to write it, okay? This here is 3n plus 3 minus 1, which gives me 3n plus 2. And the term before it is 3 less than that, which is, whoops, yep, 3n minus 1, right? Because it's 3 less than that. So when I do the absolute value of a sub n plus 1 over a sub n, that's going to be this mess here. So 1, 3, 5, dot, dot, dot. I'm going to write the 2n minus 1 so I can cancel it because I like crossing things out. One of my favorites. And then you can see where it goes, you know. 2, 5, 8, 3n minus 1, 3n plus 2. And then instead of dividing by a sub n, I'm going to multiply by the reciprocal, so I flip that. This is looking like it's going to work, right? All right, so let's start crossing. So 1, 3, 5 all the way up to 2n minus 1 is going to cancel with this, right? And 2, 5, 8 all the way up to 3n minus 1 will cancel with all of this. So all I'm left with is this. If I take the limit of 2n plus 1 over 3n plus 2, what do I get as we go to infinity? 2/3, right? Divide everything by n, I get 2/3. So this is obviously less than 1. And if we're less than 1, what happens? Convergent. So therefore, absolutely convergent and convergent, which we don't need to write both of those. And that's by the ratio test. Any questions on what I did there? Does this make sense how I wrote this? Okay, and I like to write that term before it so I can actually see it canceling out. All right, thinking through this in my head right away, tangent of 1 over n, I'm just trying to do like the test for divergence and kind of seeing if maybe, obviously alternating series isn't going to work, but you know, that test for divergence is what I try right away. If I go out to infinity, we're doing tangent of 1 over infinity, which is going to go to 0. What's tangent of 0? 0, right? Because sine of 0 is 0. So can I use test for divergence? No. Too bad, I really like that test. Yeah. Okay, I'm obviously not going to use an alternating series, integral, nothing like that. P-series, not so much. Ratio test, things aren't going to cancel if you just think about how the ratio test works, which pretty much leaves us with a comparison test, right? So if I try the comparison test, my a sub n is what I have in there, so let's write that. The thing is trying to come up with what your b sub n is going to be. Any ideas, Chen?
Well,
If you've done ones like this before, you kind of do, it seems like it's always the same, so I'll tell you, but if it's on your test, you should know how to do it now, right? So first thing that you might think is, oh, maybe I'll make it tangent of something. What do we always try to compare to? P-series or geometric series? What is a part of this that's either a P-series or geometric series? 1 over n, right? Isn't that a P-series with P equals 1? So that's what I'm going to try to compare it to here, okay? Now, if you need to, you could put this in your y1 and this in your y2 and compare the tables. Okay, which one is larger as n goes to infinity? Is it? Yeah? Okay. So a sub n is greater than or equal to b sub n, which is the first part of the comparison test, figuring out which one's bigger, right? Then I'm going to actually take this of b sub n, and I'm going to write n equals 1 to infinity. Okay, it is a p-series with what? P equals 1, right? If p equals 1, p-series does what? Diverges. If this diverges and it's smaller, does this one diverge? If the smaller one diverges, would the larger one diverge? Yes. So then we could say, therefore, a sub n diverges. Does that make sense? Sometimes. Number 27 is kind of a weird one, so I'm going to try a comparison test because that's what pops in my head first. So my a sub n is this. And then I'm going to compare it to the dominant term in the denominator is definitely the k cubed, right? And this is all one term in the numerator, so it's got to stay like this. Now, can I write that as, come on. There we go. The k and the k cubed will cancel to just give me natural log of k over k squared. All right, so looking at these, comparing these, which denominator is larger? A sub n's denominator is larger, so it's actually smaller, right? Okay, so using the comparison test, I'm using part I, if you're still using your note sheet there. So now I have to find this, right? And see what's happening there. So that is going to be natural log of k over k squared with the simplified one, and works a lot easier here, from 1 up to infinity. Now we have to try to figure out how to do this, and this is where the integral test comes in. Okay, because I have to find this piece here, Natural log of k, if I take the derivative, is 1 over k, so it's seeming like maybe that will work. Let's see what's happening here. So if I throw this in an integral, and I'm going from 1 to infinity, and we change them to x's, whatever here. So I would take the limit as t goes to infinity of the integral from 1 to t. I know that step's kind of annoying, but okay, now I would have to use integration by parts because there's two parts here. So integration by parts, I want my u and my dv, and then I'll find my du and my v. So natural log of x is going to have to be which one? Do I know how to take the antiderivative of natural log x? No, so it's going to have to be here, right? What's the derivative of natural log x? 1 over x dx. Then that would make dv what? With this. Okay, so my dv is 1 over x squared dx. And then I have to take the antiderivative of that, so you can think of it as x to the negative second. If I take antiderivative, it's x to the negative first times negative 1, right? So negative 1 over x. So now I've got the limit as t goes to infinity. And I take u times v, which is negative natural log x over x, minus the integral of v, which is negative 1 over x, du, which is 1 over x dx. That making sense? And from here we should be able to finish it, so now I'm feeling a little more hopeful. So we've got the limit as t goes to infinity, negative natural log x over x. This is going to become plus because of the two negatives here. Now the integral of 1 over x squared is negative 1 over x, right? We kind of did that up here already. So minus 1 over x. And I'm taking that from 1 to t. Any questions? I know I'm kind of going quick here. Okay, plug in t, and I have negative natural log of t over t plus or minus 1 over t. And if I plug in 1, I just want to see if it's worth taking the time to do it. Sometimes it ends up being 0. Natural log of 1 is 0, right? So this piece goes away. So I have negative 1. Does that look right to everybody? So this just becomes a positive 1. And then I should be able to take the limit of each of these things separate, right? What's the limit of, obviously this is just going to be 1. What's the limit of 1 over t? 0. And this piece here, I get infinity over infinity. I can use L'Hopital's real quick on it. So let's just do our scratch work here. So using L'Hopital's, this is negative 1 over t, and this is just 1, right? So what's that going to go to? 0. So I end up with, it looks like 1 for this. So the integral test tells me what? If this is convergent, what do I know about the series? Yeah, so this is convergent by the integral test, right? Now, hopefully this works, right? If this is convergent and it's larger, this one has to converge, doesn't it? So therefore, our original is convergent. Now, the only bad part is if this ended up diverging, you'd have to say, oh, that didn't work. But it worked here, so.
Wait, what theory is it?
We used the integral test to prove that this is convergent, and we used the comparison test to show that this is convergent also. So we used two tests in one there. Okay. So for 33, we would definitely use the root test, right? And the root test says we're doing this, the nth root, not square root, nth root of the absolute value of a sub n. A sub n is this whole thing. If I take the nth root, isn't that taking this to the 1 over n power? So what's that going to make it? Okay, so I have n over n plus 1 to the n squared, and then I'm taking that to the 1 over n. What do I do with these exponents? Multiply them. What's n squared over n? N. So it's going to be n over n plus 1 to the n power. So that's n to the n over n plus 1 to the n. Do you see that?
Yeah.
And then try to finish the root test from there. Okay.